Okay, folks, here we go. Here's our first crack at factoring trinomials from start to finish. So we know all the intermediate steps now. A lot of the times you'll hear this method being referred to as factor by decomposition. Okay? The reason it's called that is because at some point we decompose or we split up that middle term. And that's actually what gives us our four-term polynomial. And then we factor by grouping. So that's the part that we haven't done yet. Okay, so hopefully we'll put all this together into one smooth process. There are two methods that I'll show you. One is using straight up algebra, and the other one is a grid method. Now, I didn't show you the grid method of expanding polynomials, but it does exist. If you want to see that, let me know. I can show you. But I'm going to show you the grid method for decomposition. It sometimes helps some students. So once you've seen both, you can make your choice on which method you would prefer. It makes absolutely no difference to me. Okay, so let's get right in it. Here's our first example. 3p squared minus 2p minus 5. Our task or our job is to factor this, and we want to factor this into two binomial brackets, just like we had before when we were expanding, okay? So the first step is we use those number combinations that we were practicing the other day, and we look for two numbers that multiply together to give whatever 3 times 5 is, whatever this first coefficient times this constant is. 3 times minus 5, minus 15. And those same two numbers have to add to whatever this middle term coefficient is. So those same two numbers are going to add together to give minus 2. Now the hope is that you see what those two numbers are right away. If not, maybe you're doing a little bit of practice off to the side and you're going, well, what multiplies to 15? 1 and 15, 3 and 5. And then if I'm going to be adding and subtracting these together, to get a negative 15, one of these has to be negative. To get a negative 2 after we add, that means the larger of the two values has to be negative. Now I check my combinations. Is there any way I can combine positive 1 and minus 15 to get negative 2? No, this one's not going to work. Can I combine positive 3 and negative 5 to get negative 2? Yes, I can. So our numbers are 3 and minus 5. Those multiply to negative 15, and 3 and minus 5 add together to give negative 2. That's our step 1. Step 2 is now we decompose. Now we split up. We want to split up this middle term into these two values, 3 and minus 5. So we start with our 3p squared, which was there already. And then we write 3 plus 3p and minus 5p. So those two values come from the two numbers that we determined. Because when you look at it, plus 3p minus 5p, those combine to minus 2. So we're really not changing the question at all. We're just rearranging it a little bit. And then don't forget the minus 5. And now you should be thinking to yourself, hey, wait a minute, this is exactly what we were looking at yesterday. A 4-term polynomial, and we're trying to factor. So our next step at this point is t factor. Factor by grouping. Okay? So once we have our t drawn, we look at our first group, 3p squared and 3p, and we determine what the greatest common factor between those two terms are. Hopefully you see it's 3p. 3 is common between both. P's are common between both, and I choose the lowest exponent. And then if you're still working on that intermediate step, we're going to divide this by 3p and this by 3p. 3p squared divided by 3p gives me p. 3p divided by 3p gives me cancellation, gives me 1. We go to the other side. Greatest common factor between minus 5p and minus 5. Hopefully you see it's 5. And then don't forget, this sign has to come down, minus 5. And now I'm going to divide or factor out a minus 5 from both of these terms. Minus 5p divided by minus 5 is just p. Minus 5 divided by minus 5 is just 1. And then look. These are the same. These have to be the same, remember that. That is what makes up one of our factors, p plus 1. Our other factor, 3p minus 5 in brackets. And now we've completely factored this polynomial. Okay. And then I think I got lots of room. Right beside it, I'll show you the grid method. So the grid method still starts off exactly the same. We still need to find these numbers. Once you've found these numbers, well, then you take a different set of steps, okay? So we still have to find these numbers. Then I draw myself a grid. Basically a 2 by 2, 3 by 3 grid, really. 1, 2, 3, 1, 2, 3. And I fill in inside this grid. I put my 3p squared, top left corner, 3p squared. I put my constant minus 5, bottom right corner. And then in the other two places, I use these two numbers that I've found, and I fill those into my empty boxes. 3p minus 5p. So I'm still decomposing, I'm still doing the same steps. Okay. Now I just look column and row. I look at columns and rows. I want to know what the greatest common factor between 3p and minus 5 is. Greatest common factor between 3p and minus 5? Well, there isn't anything fancy other than a 1. I look for my greatest common factor between 3p squared and 5 minus 5p. And you should just see a p. Then I go my columns. I look for my greatest common factor between 3p squared and 3p, and I see that that is 3p. And then my last one, greatest common factor between minus 5p and minus 5, that is a minus 5. So the key is, if you ever get this first term, like in this spot, I'm working down my column, my first term that I came to was this minus. If you ever come across that first term as being minus, you factor out that minus sign. Okay? Or that same rule. Both of these are minus, factor out a minus. We talked about that in a couple lessons ago. And then this is what forms our factors. P plus 1, 3p minus 5. You can see we get exactly the same thing. P plus 1, 3p minus 5. That is factoring by decomposition. I'll do one more example doing both methods, and then I will leave you be to try on your own. Okay. Number 2. 2n squared plus 3n minus 9. First step, I'm looking for two numbers that multiply together to give 2 times minus 9 minus 18. Those same two numbers add together to give 3 plus 3. What are my options for 18? 1 and 18, 2 and 9, 3 and 6. I know they multiply together to give a negative, so one of them is negative, and they add together to give a positive, so the bigger one has to be my positive value, my smaller one is negative. Which of those combinations add together to give 3? Minus 3 plus 6. 6, negative 3, adds together to give 3. 6 times negative 3 gives me negative 18. Okay. So that's the first step in both grid factoring and factor by decomposition, is to find those values. In factor by decomposition, once we found those values, I decompose my middle term. I split my middle term up. Boom, boom. Draw arrows if you want to make sure you remember that you need to do that. 2n squared plus 6n minus 3n minus 9. Then I've got my 4-term polynomial, and I factor by grouping. Draw my t. and factor. Greatest common factor of 2n squared and 6n is 2n. And then, of course, that intermediate step, I'm going to divide both of these by 2n. 2n squared by 2n leaves me n. 6n by 2n leaves me 3. I go to my next bracket, minus 3n minus 9. My greatest common factor is a 3. Remember, it's got to be a minus 3 because this is minus. If I factor out a 3 from both of these terms, minus 3 divided, not just a 3, sorry, a minus 3. Minus 3 divided by minus 3 is just a 1, so I just left n. And minus 3 divided by, sorry, minus 9 divided by minus 3 plus 3. And again, look, these have to be the same. So that's one of my factors, n plus 3. My other factor is made up of 2n minus 3. Done. Okay. Hopefully that gives you a bit of a kickstart on factoring trinomials. You got a few questions left on this page. Those of you that are picking this up from elsewhere, there is the first 4 questions. You can pause the video, write that down. There's the next 4 questions. You can pause that video and write that down. Over the page for 8 more questions. There's the first 4. And the last one. Now, I will caution this. Remember, when we talked the other day, the first step in any factoring question is greatest common factor. There's a couple of these questions in here that you have to do a greatest common factor first before you try this, or it's going to get really messy and really ugly. Okay? Good luck. Give it a whirl. See what happens. I'll catch up with you next day.